ever try to stuff like a week's worth of clothes into one of those tiny carry-on bags?
You mean you have to actually try to make that happen?
Huh. Yeah, well, I'm assuming most people do, using those special folding techniques or even those vacuum bags.
Those vacuum bags are a game changer, though.
Right. That's kind of what we're diving into today, but in the world of Linux.compression, but from a hacker's perspective. We'll be looking at excerpts from Linux Basics for Hackers to see just why compression is so crucial in cybersecurity.
It's like this, say a hacker is trying to, I don't know, maybe slip a malicious program onto a system without being detected. Or even, steal an entire database without tripping any alarms. Smaller files are stealthier files.
Okay, yeah, it makes sense when you put it that way. So we're talking about basically like zipping files. Is that the kind of compression we're dealing with?
It's similar, but Linux has like a whole toolkit for this kind of thing. And just like you wouldn't cram your dirty clothes and your clean clothes into a suitcase altogether, hackers often need to combine multiple files before they actually compress them. That's where the tar command comes in.
Tar. Like tar pits? Sorry, that sounds a bit menacing, even for a hacker.
Not quite. The name is a bit of a throwback, I'll admit. TAR stands for Tape Archive. Remember those old cassette tapes?
Oh, yeah.
Think of it kind of like making a mixtape, but instead of songs, it could be code, scripts, any type of file, really.
Right. I can picture that. So how does this tar thing actually work in practice?
So let's say a hacker has those 3 scripts from our source material. Hackers Arise 1, Hackers Arise 2, and Hackers Arise 3. To bundle them all together into one neat package, they would use the command tar-cvf hackersarise.par and then follow that with the names of each of the script files.
The CVF part is kind of like giving the tar command specific instructions.
Yeah.
What are those instructions exactly?
You got it. The C tells it to create the archive. The V stands for verbose. That basically means it lets you see the files as they're being added, but that's optional. And then F just means file. It tells tar to actually write the output to the file name that you specify, in this case, hackersarise.tar.
Okay, so we've got our metaphorical suitcase packed with our hacker tools, but it's not actually compressed yet, right? It's just bundled together.
Exactly. Think of tar as more like organizing the suitcase,
Wow.
not shrinking it down. And just like a suitcase has some weight to it even when it's empty, tar adds a little bit of what we call overhead to the files. Our source material mentioned the file size actually increased slightly after using tar. That's that overhead.
Interesting. So even that small increase in file size could actually matter to a hacker who's trying to stay under the radar.
Absolutely. Every byte counts when you're trying to be discreet. But that's where the real magic of compression comes in, right? It's like choosing the most efficient packing technique to make that suitcase even lighter. We're talking about algorithms like gzip, bizip2, and compress, each with its own way of shrinking those files down.
Okay, now we're talking. It sounds like things are about to get really interesting. Time to break out the compression shrink rays. All right, so we've got our little metaphorical hacker suitcase all packed up using tar, but now it's time to shrink it down. You mentioned these compression algorithms, gzip, bizip2, and compress. So I'm picturing, I don't know, some serious digital origami happening here, right?
That's actually a great way to think about it. Each of these algorithms is like a different packing technique.
Okay, I like that.
So let's start with gzip. Gzip is kind of like if you just roll your clothes. It's pretty common. It gets the job done decently well, and, most systems are going to recognize it. So a good all-around choice.
Makes sense. So that's kind of like the go-to method for most people packing a suitcase.
Yeah.
But then we've got bzip2. Our source material makes bzip2 sound like it's for the truly efficient packers.
Exactly. Think of bzip2 more like using those vacuum sealed bags.
Oh, yeah?
Yeah. It takes a little bit more time, a little more processing power, but you can get significantly smaller file sizes, especially with large files.
Got it.
And for hackers, that means, they can sneak larger exploits onto a system or maybe steal a massive amount of data without attracting as much attention.
So that's why bzip2 is the hacker's best friend when they need to be extra sneaky. But what about compress? It kind of made it sound like, sitting on your suitcase to try and get it to shut.
Yeah. Compress, let's just say it's the old school method. It's still around. It might be useful in very specific scenarios, but overall, it's not as efficient as gzip or bzip2. So hackers probably aren't going to use it unless they're working with older systems. Or maybe they need to make sure things are compatible with something for whatever reason.
So it's like trying to, send a message using smoke signals when everyone else has moved on to smartphones.
Exactly.
So let's go back to our hackersarise.tar example. Our source typically gives us some numbers on this. How much did each of these algorithms shrink that file down?
Well, remember that the tar file was around 40,960 bytes.
Yeah.
Well, gzip got that down to about 3,299 bytes.
Wow. That's like going from a bulky suitcase to like a sleek messenger bag.
Right.
But bzip2 took it even further, right?
Oh, absolutely. bzip2 got it all the way down to 2,081 bytes.
No way.
Almost unbelievably small.
That's amazing.
And just a handy little tip here. You can usually tell which compression method was used just by looking at that file extension. So that's going to be like tar.jz for gzip, tar.bzip2 for bzip2, and then .tarz for compress.
Okay, handy. It's amazing how much goes on behind the scenes with like just a few, simple commands. It's like having a team of expert packers at your fingertips.
Right.
But speaking of powerful tools, we do need to talk about the DD command.
Oh, yeah.
Our source called it the hacker's Swiss Army knife.
Yeah.
I have a feeling this one comes with a bit of a warning label.
Yeah, you're right to be cautious. DD is incredibly powerful. So imagine you need to, I don't know, recover some deleted files. Or maybe, from a forensic investigator's perspective, they want to try to track down traces of hacker activity. DD is going to be their go-to tool. It can actually create a bit-by-bit copy of an entire hard drive that includes those deleted files.
Wait, so even when you think you've deleted something, it's like still lurking around somewhere?
Yeah.
That's both fascinating and a little terrifying.
That's the thing about data. It's way more persistent than you might think.
No.
And DD can be used to access it. So if tar is like packing our suitcase and gzip is sitting on it to get it to close, DD is picking up that entire suitcase, putting it in like a high-tech scanning machine, and it creates a perfect replica, even down to the scuff marks.
Okay, now that's a visual.
Right.
So how does one even begin to wield this DD command? It sounds pretty complex.
It is powerful, but the basic syntax is actually pretty straightforward. So let's say, for example, you wanted to make a copy of a flash drive. Our source gives a good example. The command would look something like this. dd if dev sdb of root flash copy vs4096 convia error.
Okay, there are a lot of letters and symbols in there. Can we break that down a little?
Absolutely. So if just stands for input file. In this case, that's going to be our flash drive, which Linux is going to identify as dev sdb.
Okay.
The of just means output file. That's where we're actually sending that copy. And in this case, we're just giving it, a descriptive name like flash copy in the root directory.
So far, so good.
Yeah.
But what about the rest of that command? What's that BS4096 convia error? Those parts seem important.
They are. BNS refers to what we call the block size. Basically, how much data DD is reading and writing at a time. So a larger block size, like the 4096 we have in the example, that speeds up the whole copying process. That can be super crucial if you're trying to, say, make a copy discreetly before anyone notices.
So it's like choosing a bigger shovel to move a pile of sand, fewer trips back and forth.
Exactly. And then that convia no error part, that's super crucial for reliability. What that's doing is it's telling DD to just keep going, even if it happens to encounter any errors, which can totally happen, especially if the storage device is like damaged or corrupted.
Right.
And this is especially important in a forensic situation where you need to recover every single bit of data, even if it's a little messy.
Yeah, that makes sense. It's like telling the command, like, just keep swimming, even if it hits a snag.
Exactly.
But maybe not something that the average user should be messing around with without the proper guidance, right?
Yeah, you're absolutely right. Our source stresses caution with DD for a reason. It's a really powerful tool. And, as they say, with great power comes great responsibility. One wrong move and you could accidentally overwrite, your entire system.
Well, that's a sobering thought. We've covered a lot of ground here, from the basics of tar to this impressive compression power of gzip and bzip2, and then even these potential, hazards of the DD command. It's like we've peeked behind the curtain of a hacker's toolkit, learned how they're manipulating data to kind of achieve their goals.
And we've only just scratched the surface. The world of Linux compression is huge. Tons of possibilities, both for good and for, well, let's just say less than good purposes.
Which kind of brings us to the big question. What does it all mean? We've explored the what, but what about the why? Why should this matter to our listener? It's kind of like we've learned, I don't know, like a magic trick, right?
Right.
Knowing how it's done just gives you a whole new appreciation for what looks like a simple illusion.
Precisely. And just like a magic trick, these compression techniques, they can be used in so many different ways. Some, more obvious than others. Take data recovery, for example.
Yeah.
Knowing how to use DD could be the difference between, recovering those precious files and losing them forever.
Oh, that's a really good point. It's not all about hackers trying to be all sneaky and stuff. This knowledge has some very real world, like practical uses for just your everyday user too.
Absolutely. Think about like backing up your data. Using compression can save you a ton of space and bandwidth, which makes the whole thing faster, way more efficient. It's all about understanding the tools that are out there.
Right, right. So it's like, in a way, this knowledge, it's power. And
Yeah.
like with any kind of power, you can use it for good or, well, not so good.
Exactly. And that's what I think is so fascinating about the world of Linux. It's this amazing playground for anyone who's even remotely curious about how technology actually works under the hood. But it's also, a constant reminder that with that knowledge comes responsibility.
Yeah. It's like
Yeah.
we've been given the key to this, like secret room full of all these powerful tools. And now it's up to us to decide what we're going to do with them.
I love that analogy. We've equipped you with the knowledge of tar, gzip, bzip2, even the mighty DD. It's out there. Now it's really up to you to decide how deep you want to go, what you want to create, what problems you want to solve.
It's all out there. Right.
It is.
So to our listeners out there,
Mm.
what will you do with this knowledge?
Mhm.
How are you going to use this to explore, I don't know, the vast and always changing world of Linux? The possibilities are, as they say, practically limitless.
Truly they are.
Until next time, happy hack.